Alkaptonuria is a rare inherited metabolic disorder caused by a deficiency of the enzyme homogentisate 1,2-dioxygenase (HGD), which is involved in the breakdown of tyrosine and phenylalanine. Here is the step-by-step pathophysiology of alkaptonuria. 1. Amino acid metabolism begins. The essential amino acid phenylalanine is first converted into tyrosine. This is a normal step in amino acid metabolism. 2. Tyrosine is further degraded. Tyrosine is then metabolized in the liver through a series of steps. Tyrosine, p-hydroxyphenylpyruvate, homogentisic acid, HGA. Deficiency of homogentisate 1,2-dioxygenase, HGD. Normally, HGA is broken down by the enzyme HGD into malolacetoacetate. In alkaptonuria, due to a mutation in the HGD gene, this enzyme is deficient or non-functional. 4. Accumulation of homogentisic acid, HGA. As a result, HGA accumulates in the body. It builds up in tissues. It is excreted in the urine. 5. Oxidation and polymerization of HGA. Accumulated HGA is oxidized to benzoquinone acetic acid. This product polymerizes and forms pigmented polymers. These dark pigments deposit in connective tissues, a process called ochronosis. 6. Effects of pigment deposition, ochronosis. Deposits accumulate gradually over time in cartilage, leading to brittle joints and arthritis, skin, bluish-black discoloration, sclera, pigmentation of the eye, heart valves causing valvular disease, kidneys may form stones. 7. Urinary excretion of HGA. Excess HGA is also excreted in urine. When exposed to air oxidation, the urine turns dark brown or black, a classic sign of alkaptonuria. Summary flowchart. Phenylalanine, tyrosine, p-hydroxyphenylpyruvate, homogentisic acid, HGA, blocked in alkaptonuria, X-homogentisate 1,2-dioxygenase deficiency, accumulation of HGA, oxidized to pigments, deposits in tissues, ochronosis. Key genetic note, inheritance, autosomal recessive, gene affected, HGD gene on chromosome 3q13.33. Thank you. Have a nice day.